agricultural science focused on imaging spectroscopy for non-destructive quality measurements in fruits, which he did at the Miyazaki University of Japan in 2006. Dr. Jasper did a short stint as a postdoctoral researcher at the Kansas State University on air quality monitoring and at the USDA Agricultural Research Service on spectroscopy for seed quality, both located in Manhattan, Kansas, United States of America. His current research interests at the PhilRice deals with electronics and instrumentation for rice agriculture spanning on microcontroller and sensor technologies, robotics, and computer programming, among others. Without further ado, let us welcome Dr. Jasper Tallada, Supervising Science Research Specialist of the Philippine Rice Research Institute, for his talk, Smart Farming Technologies to Philippine Agriculture.
Dr. Jasper, can you turn on the video?
And microphone.
And microphone. Doon po sa tabi ng screen share, paki-on po yung microphone nyo and then also video. Okay.
Yan, okay? Okay.
Okay,
Thank you.
that's good. Thank you.
It's the other way around. Okay, good afternoon, everybody. I'm Jasper Tallada of Philippine Rice Research Institute. Magandang hapon po sa ating lahat. Minasan konnichiwa. Mukhang nami-miss ko na mag-Japanese. Anyway, way back 2012, 2013, I was involved with Picard, DOST, for doing some training on microcontrollers for instrumentation, for sensing and control. At that time, the early concept of smart farming, we are trying to develop that. At that time, parang ang aming perspectives ay for automation of farming. Then in 2018, I participated in a forum organized by the Asian Productivity Organization, and at that time, they were talking about Industrial Revolution 4.0, or particularly Agriculture 4.0. And it was very, very new to me, okay? And I didn't know that what we were doing in smart farming is actually part of Agriculture 4.0. Upon returning back at PhilRice, I asked my colleagues, have you heard of Agriculture 4.0? Sabi nila, hindi po. Wala silang clue kung ano yun. Then I asked Picard, I have some friends at Picard, and ganun din sabi nila, we don't know Agriculture 4.0. So, that was 2018, 2019 came, then now 2020, ayan na po ang Agriculture 4.0. And I'm so happy that we are having this webinar on that topic. Nakita ko talaga yung progress, the interest on this concept of Agriculture 4.0. Okay? Now, let me proceed with my presentation, Smart Farming Technologies for the Philippine Agriculture. Probably we are all aware that Agriculture 4.0 is still very, very new to the Philippines. Okay? Sa ngayon, more or less, people associate that with smart farming or farm automation, and probably sa ngayon, I'm going to present more on those technologies. Okay. Now, let me first give you an overview or bird's eye view of what I'm going to discuss. Kanina may mga questions about why are we not sufficient with rice? I'm going to very briefly tackle on that. Then some of the many smart farming technology solutions that we are trying to develop and promote here in the Philippines. And at PhilRice, we are trying to promote digital farming. Meron kaming platform called PhilRice. And of course, the next wave after all this. Now, sinabi kanina, bakit ito yung parating question na tinatanong sa atin, bakit ang Pilipinas ay hindi maka-achieve ng rice self-sufficiency? Okay? Unang-una po, napakababa po ng, napakaliit po ng ating agricultural lands. Comparing our agricultural lands with Indonesia, Thailand, Vietnam, we have one of the smallest or littlest agricultural land po. Kaya napaka-konti lang po available areas natin for crop production. Then aside from that, mataas din po ang ating cost of production. We have very high cost of production relative to other countries. That's why they're telling us that it's so difficult for us to achieve competitiveness in rice crop production. We belong to those countries with a little bit higher, not a little bit, significantly higher cost of production comparable to Indonesia and China. And all of these countries are net importers of rice. Compared to Vietnam, India, and Thailand, ayan po, mababa lang kanilang cost of production. Like Vietnam can get a kilo of palay for 6 pesos and 53 centavos. Whereas the Philippines is about 12 pesos and 41 per kilo. So marami tayong hahabulin when it comes to cost of production. Another big problem is our ever-increasing population. In 2015, it is estimated to about 101 million. And it's growing about 1.84% annually. About 2%, no? 1.8 to 2%. Okay? Ang ating population density is about 347. Compared to Malaysia, they only have 95. Okay? Now, from 2015, 101 million. By 2030, it's estimated to be about 128 million. And by 2040, that would be about 142 million. Imagine, in 20 years, about 40% of population will be added. Okay? Napakadaming pakakainin po sa Pilipinas. Pag pinag-uusapan po ang pagkain, each person is consuming about 110 to 114 kilograms annually. Sadyang mahilig kumain po ang mga Pilipino ng rice. Okay? It goes as high as 120 in some provinces, kilograms per capita. Okay? Now, andyan din po ang risks due to typhoons. Everybody knows that more than 20 typhoons visit our country. Okay? And recently we had experience with Typhoon Rommel, and Typhoon Ulysses that really a lot of areas get flooded, a lot of crops were destroyed. Medyo common na sa atin itong problemang ito. Then ang Pilipinas, although increasing now over the years, nag-increase yung ating production because of the different technologies that we are trying to generate, the varietal technologies, the farming technologies, pero tumataas din po ang ating total consumption. That means we really need to import rice. Although we are the 8th largest producer of rice in the world, we are the 2nd largest importer of rice. Sometimes tayo ang nagko-command ng prices, no? Kasi tayo ang buyer po sa world market. Okay. Now, so these are the challenges that we have, especially for rice crop production. We have high population. Andiyan pong risk due to climate change and disasters. Okay? Di ba? Sumabog ang Taal last December. Okay, so yung ashes fell on the rice lands. So that would also diminish the agricultural areas. Okay? Then we have the shrinking agricultural lands due to conversion, other uses. Okay, naging malaking problem ito sa land conversion. And of course, the input to crop production like fuel, tumataas din po. Although ngayon po relatively mababa ang fuel price, ang crudo, pero over the years tumataas po ang ating kasi diyan nakabase din po ang cost of fertilizers, cost of chemicals due to the fuel costs. So, punta na po tayo sa concept ng Industry 4.0. So, it's been happening since 2011 in Europe, particularly in Germany nga po, no? Sa kanila kasi more on integration of different manufacturing practices or processes. okay, involving many components of production, streamlined nila. That's why they have this concept of 4.0. There's a massive application of information and communication technologies, pati po manufacturing technologies na andyan po. Siguro narinig nyo na po yung book na The Third Wave by Alvin Toffler. That's Industry 3.0, more on the application of ICT, okay, sa different aspects of human life. Ngayon, itong Industry 4.0, ito na yung paggamit po ng mga Internet of Things, mga robotics, mga networks, okay? Actually, may nagsasabi na, tayo ay nasa Industry 5.0. That's between 4.0 and 5.0 na po. Okay, but still, let's call that as Industry 4.0. And from there, we have the Agriculture 4.0. Now, let me discuss with you the different smart farming technology solutions that we can use or we can adopt to enhance our farming, no? But first, ang word smart farming comes in many names. We have heard of precision agriculture, okay? We have heard of precision farming, or SSNM, or location or site-specific crop management, or sabi ng iba, nutrient management. These are just names referring to smart farming, okay? We are going high-tech in doing farming. Now, when we talk about 4.0, we talk about the technology of Internet of Things. Simple lang po ang concept ng Internet of Things. We have devices, electronic devices, which are addressable, okay? Network addressable. Ibig sabihin, they can be connected to the Internet cloud, and they can send data to the cloud, and they can also get commands or controls from the cloud coming from the servers. So yun basically ang Internet of Things. Lumabas ito there was a big interest in IoT because of the development of the different microcontroller platforms. Okay, these are smart devices, smart boards with microcontrollers. Not only the CPU, but you have the memory, you have the clock, you have the control ports present in those boards. So, nung early 2010, 2009, naging popular po ang Arduino. Maybe some of you have heard about Arduino. Then after that, there had been a proliferation of other microcontroller platforms. Andyan na po ang Wemos, na naka-integrate na po ang Wi-Fi na, na controller board. In a very small board, may Wi-Fi ka na. Then, Raspberry Pi came after Arduino. It's a single board computer na mataas ang kanyang memory, mataas ang kanyang processing power. Andiyan na rin po ang kanyang peripheral interface. You can connect USB devices, you can connect cameras into that board. Then lumabas po after Raspberry Pi, another version of it called Orange Pi. Okay, based on Raspberry Pi. All of these are mga open source technologies, open source. Any manufacturer can copy the design of these boards. Actually, meron po tayong Banana Pi pa, another flavor of Raspberry Pi. Then, recently, meron tayong NVIDIA Jetsons na mind-boggling itong microcontroller board na ito. Kasi, they are now positioning this board for artificial intelligence. You can teach the board how to recognize images, count objects and images. Gumagamit siya ng mga graphics processing unit, mga GPUs na ginagamit normally sa gaming, ngayon ginagamit nila for artificial intelligence. Also, there are proliferation of environmental and optical sensors. Meron tayong sensors for temperature, for RH, for soil moisture, pH. Marami na po nag-proliferate, kaya naging madali na po ang sensing. Optical, you have cameras, you have light-dependent resistors, and so on. For controllers, meron na tayong mga solid-state relays. We have motor drivers. You can control big motors using a very small board. And of course, importante po ang communications. RF, radio frequency, Zigbee, LoRa stands for long range. Dati-rati kasi you can only communicate as far as 200, 300 kilometers. Ngayon ba, pinag-uusapan 20 kilometers, 30 kilometers. That is LoRa. And of course, Wi-Fi. Andiyan din po ang Bluetooth and other communications platform. Probably you have heard of Alexa with Amazon. It's shown on the lower left sa screen natin. Yan po, that's also based on Internet of Things. You can even issue mga verbal commands. Alexa, timer 20 minutes. And it will do a timer. Alexa, what's in the news? It will explain to you some news. Meron din mga son-off devices. These are IoT devices that allows you to control devices in your house like electric fans, heaters, and so on. Okay, so because of the proliferation of these network, uniquely addressable network devices for sensing and control, dyan na po lumabas ang Internet of Things. So massive integration of different devices. So sa PhilRice po, we also have works on IoT. Meron po kami mga monitors, okay, which we place on different parts of a farm. Yung mga orange dots po, yun ang IoT namin. It can sense temperature, RH, soil moisture. Okay, we are trying to deploy them in the farm, and automated po ang pag-capture ng mga data pong ito. Yan po. This is one thesis student from UPLB actually, who is he is an electrical engineering student. He worked on the IoT, no? We asked him to develop with us the IoT device. Pero yung design namin yun basically, siya lang yung nag-put them together. Okay, we can do that for crop health, like height and color, microclimate, like canopy temperature, humidity, drip irrigation control, okay, water quality monitoring. We can do pH, electrical conductivity, temperature, and of course, automating the hydroponics. Okay? Yon, going to hydroponics, pag sinabing smart farming, hindi mawawala ang hydroponics where we have good control sa nutrient management ng crops, no? In a recirculating manner. And hydroponics already comes in different names and different systems like nutrient film method, floating wrap, or deep water hydroponics. Yung ebb and flow, yung taas-baba lang, taas-baba ng nutrient solution. Yung non-circulating hydroponics, to yung crack kit na tinatawag na coming from Hawaii, yung technology na yan. Andyan yung Dutch bucket, the rain gutter, ang dami po, aquaponics, aeroponics, vertical farming or vertical hydroponics, and meron po tayong field hydroponics. Actually, para lang siyang Dutch bucket systems. So marami na po tayong, ang CLSU po is quite popular when it comes to hydroponics. Go to YouTube. You can search a lot of farms here in the Philippines who are already doing hydroponics. Pati na rin po mga suppliers, okay, for the different inputs. Then ito po, yung concept po ng plant factory where you grow, where you're basically using the hydroponics technology but you grow crops inside enclosures, inside buildings, okay? Ito yung ginagamit to for vertical farming normally to maximize the use of the area. Japan has been pioneering in the concept of plant factory, no? And I was able to talk with the author, Okizaki ba yun? Na original author ng plant factory concept. Sabi niya, that time when we had the forum, there's a declining interest in plant factory because it's damn too expensive to operate one. But alam nyo ba, during the Fukushima disaster, because of the radiation na na-spread next to the nuclear reactors, nagkaroon po ng revival of the plant factory because they cannot rely on the irradiated land for crop production. So, yan po. Then of course, andyan din po ang drip irrigation for large scale, for orchards, or also for vegetables, no? For ano. And if you're going to put there the nutrients, tawag na po doon ay fertigation. So, matagal na po ito, 1970s, 1980s technology po to na inumpisahan po ng Israel. Okay? Because they have a little access for water. Then, dyan na po ang paggamit ng satellite. Sa ngayon po, no, satellite technology. Ginagamit natin siya for communications, for monitoring, and so on. Lalo na ngayon, may mga open satellites na po. Okay? Na you can download data from this satellite. And we made use of this technology in the partnership collaboration between ERI and PhilRice called PRISM, which stands for Philippine Rice Information System. So in this project, Okay, this is a ERI DA PhilRice collaborative project. We can do remote sensing, satellite-based monitoring of the production areas for rice. Okay, using the satellite technology, yung Sentinel na satellites. Okay, kasi ang kagandahan niya, meron siyang synthetic aperture radar. Okay, na kaya niya mag-penetrate ng clouds. Okay, unlike yung mga ordinary image cameras, pagka meron ka ng clouds, di mo nakita sa ilalim ng cloud. Pero siya, na-penetrate niya yung clouds na yon. And the good thing about this is that you can distinguish land from water. Ganun po, land and water. Ngayon kung previously, alam mo na isang area, it used to be planted with rice, tapos na-detect ng satellite na may tubig o basa siya, there's an increased likelihood, there's a good probability na meron siyang tanim na rice. So with PRISM, na-estimate po yung mga planted areas, okay? Tapos pag alam nila kung kailan tinanim, may estimate din po nila kung kailan siya mag-harvest at ano ang kanya magiging yield. So ito po siya, gumagamit siya ng isang process-based crop modeling called ORIZA. Ini-integrate ng ORIZA yung spatial information, the weather data, okay, and so on, para magkaroon siya ng forecasted yield. So it will look something like this, no? It can detect the planted areas for rice and then estimate the yields for that. So nagiging ano siya, parang in parallel, okay? Ang officially nag-estimate kasi ng yield o nagpo-forecast ng yield sa atin ay yung PSA, the Philippine Statistics Authority. Okay, dating BAS na nilipat sa PSA. Kaya silang gumagawa. But they do that manually. Here, we do that in an automated manner. Kaya, di rin mawawala po yung apps, especially the mobile apps, no? When we talk about Agriculture 4.0. Like itong RCM or Rice Crop Manager, this was also the co-developed between ng ERI and PhilRice, where we give advisory to the farmers on how much fertilizers to apply and when and how to apply those fertilizers. Meron po tayong app for that. So we do clinics like this where farmers can ask, like given yung area nila, in condition ng kanilang area, ng land nila, and RCM can suggest like if you need to add zinc, okay, sa mga flooded areas kasi importante po ang zinc. Then we also have an app called MOWET or -1 element technique. It's a technology developed by PhilRice, okay, where we systematically remove one element. Mayroon tayong mga test pots of rice, no? And systematically we remove one nutrient in the formulation. Okay, then titingnan natin yung reaction ng plant when we remove that nutrient. And based on those reaction, mako-compute po ang how much fertilizer to apply dun sa plant. That's the -1 element technique. Then of course, meron tayong AgriDoc. AgriDoc is more of a recording app, no? Yung mga farmers could easily record kung kailan siya nagtanim, ano ang kanyang mga in-apply na chemicals, fertilizers, and so on. Kailan siya nag-harvest, how much yung harvest. So, kino-collect yung all data na yun. Tapos later on, the farmers can get insight on the productivity of na kanyang area. Ano yung pwede niyang i-tweak sa next production. Okay? Can also do, as written here, yung mga farm geo-visualization. Kasi parang ano lang yan, parang Google Maps. Okay? Okay, and mga crop growth transition notification, for example, sasabihin niya na plants mo ay nasa panicle initiation stage na, napaka-sensitive na yan, so huwag mong kakalimutan ang irrigation pagka nag-PI ka na. Okay, pest and disease alert, vital information, and so on. Okay, now moving on, next is one of the popular app na dinevelop sa PhilRice na tatawag namin BP app o Binhing Palay or Rice Variety app. Andun po sa app na to nakalagay po ang ang profile po ng bawat variety. Kasi yung tinatanong nila parati, gaano kataas bang ani ng RC222 compared sa RC160? So this app will tell you that. Pati yung kanyang grain quality, milling potential, hardness, and so on, pwede pong ibigay ng app na ito. Ito yung meron kaming downloads kasi yun ang parating tanong ng mga farmers. Ano ba tong lalo na yung tatanong niya, ano ba latest nating variety? Andyan po sa BP app. Then sa namin recently developed is the weed recognition app. Okay, by shooting or by getting an image of the plant, picture lang niya, ma-identify na kaagad kung anong species siya. Okay? Right there sa app mo, you don't have to be connected sa internet. Then pati po yung control, sasabihin niya na rin po ano yung appropriate chemical to be applied kung gusto mong i-control yung weed na yan. And of course, andyan po ang robotics. Okay? Pag pinag-usapan na yung field automation, we really need robotics technology. Marami na pong nagwo-work on this, especially abroad, no? Field robots. Kung napanood nyo yung Interstellar na movie, doon po naka-feature yung mga robots po doon na nagulo yung GPS tapos nawala ng yung robots. Okay? Itong video na pinapakita, this is being developed right now by UST, si Dr. Anthony James Bautista po. And explain niya po how they developed this autonomous robot. This is Picard funded na mag-isa kayang tumakbo ng robot. Yan ang gusto nilang pakita. Autonomous kung tawagin nila. Actually, this 2 steps to 3 steps forward na siya. Okay? Sabi ko nga sa kanila, sana remote control na muna siya bago siya maging autonomous. Pero actually capable din siya for remote control operation. Then, drones or unmanned aerial vehicles, these are staples na po ng Agriculture 4.0, paggamit ng mga drones. And we can use drones, firstly, for crop monitoring. We can use them for crop spraying. And right now, we can also use that for seeding. Sa PhilRice, we were able to demonstrate that you can get 20 kilograms per hectare seeding rice. Okay, 20. Actually, mahirap magawa yon with manual broadcasting. Mahirap ma-achieve yon. Uniform ang iyong application ng seeds. But with drones, you can achieve 20 kilograms of seeds per hectare. But mostly, it's very good for monitoring. No? Like in PhilRice, we have the fixed wing and the multi-rotor. Okay? We can do aerial capture para namin visually ma-analyze yung state of crops. Okay? Where are they planted? Meron pa bang nahuhuli sa planting? Yan, we can do that. And we can do low altitude rice monitoring for computation of vegetation indices. Okay, like this one. Okay, the normalized NDVI, normalized difference vegetation index, itong normalized green-red difference index, another vegetation index siya. Okay? Now, we can now do a pseudo color mapping para malaman natin alin yung medyo mababang nutrients o mataas ang nutrients o ano yung ina-attack ng insects and so on. And for the promotion and deployment of digital farming, kanina pinag-uusapan natin ito. We are trying to develop these advanced technologies for farming. Ang problema ngayon, maipapasa ba natin to sa mga kabataan, sa mga anak ng farmers? Okay? Tumatanda na po kasi ang farmers natin, average age about 57 years old. Tumatanda na po sila. And we really have to make farming sexy to the youth, sa mga kabataan. So we have an agritourism farm at PhilRice called PhilRice. Ito yung aming platform for demonstrating all these advanced technologies. Okay? We now use this for the regular lakbay palay or farmers field day. But aside from that, we also invite mga schools, mga turista to visit us. Like you can see the paddy art up left. Okay? Para magpa-picture. Okay, makita na you can also do some art using palay. Okay? And pinapakita yung mga monitors, yung mga IoT devices, yung effects ng apps like Rice Crop Manager against Mowet app, tapos ipaggamit ng drones. And recently, we also have the automated irrigation control in gate. Pang-control, we can do that sa PhilRice. Okay? So, ang idea kasi, we really have to make farming exciting to the youth by showing them alternative farming options. We can make use of computers, we can make use of satellite, of drones, to make farming really, really high-tech, okay? And something to be enjoyed about. And what would be the next wave for smart farming or agriculture 4.0? Okay? Ang isang parating buzzword pinag-uusapan ngayon ay yung concept ng big data analytics or the artificial intelligence, where we try to aggregate, okay, any data, okay, to one holistic system, and based on that aggregated data, you can make insights or analysis on what to do, and it will also, you can translate that in sa kanyang economics. For example, siguro lahat naman tayo dito ay nakagamit na ng Lazada or Shopee. Okay? Each time that you use that app, you are throwing data to the servers. Alam nila iyong buying pattern. Ano yung mga alam nila kung anong iyong paborito. And they try to suggest to you something na related to that. Bumili ka ng item A na nito, alam nila associated siya sa item B. Sasuggest nila kagad sa yung item B na yon to go with your item A na binili mo. So, yan po. Ayan, isang paggamit ng big data. Okay, so ini-integrate with agriculture, we can integrate yung mga ground sensors natin with the data from the drones. Tapos may apps tayo, then mga devices like the Internet of Things. And through an artificial intelligence, we can do some insights. Mamaya may explain pa ako how can we really operationalize this one. So ito yung tinatawag na, sa akin po, this is my concept called the great integration. Yeah, and it comes in demand forecasting. Okay, like sa Pilipinas, no, marami tayong mga bayan-bayan. Okay, tapos yung mga tao kasi sa bawat bayan-bayan, iba-iba ang kanilang patterns or calendar of demand of food. Diba? Alam natin, pag piyastahan, mataas ang kanilang consumption ng food. Pagdating po ng Christmas, ang taas na po consumption ng pork, ng chicken. Pero pagdating ng Lenten season, mababa ang demand sa pork. Pag pumunta kayo ng Mindanao, mababa ang demand for pork. Mataas ang demand for chicken. Mga ganun ba ang kung mapofocus man lang natin siya, we can now backtrack. Okay? Una yung logistics. How quickly can the different channels deliver those food? Ano yung mga transport channels natin? Okay? Lalo na sa Pilipinas, sa multi-island, problema po ang logistics. Ano yung magiging climate outlook for next year? Magkakaroon ba tayo maraming typhoons? Will there be a lot of rains? Ganun po. And then alam natin yung mga performance ng production systems. Alam natin anong areas ang magaling sa onion, magaling sa vegetable, magaling sa mga fruit trees. Okay? Mapoproject po lahat yan. And once you backtrack them, you can now schedule everything based on that demand forecasting. So we can maximize what the available, we can maximize the food produced sa demand ng mga consumers. Ayaw natin mangyari yung, for example, onions. Pag tag-anihan, halos tinatapon na ang sibuyas, 5 pesos per kilo, 2 pesos per kilo na lang. Pagka tag-anihan. Pero during other parts of the year, umaabot siya ng 90 pesos, 80 pesos per kilo. Ang laki ng disparity. So, we can only do this if we apply big data. We could integrate all those data into one system and do these projections and do this analysis. Ang sadly sa case ng Pilipinas, we don't have enough good data, clean data na nako-collect. Okay? Kasi alam ko kung minsan like yung presyo sa palengke, kino-collect yun, minsan butal-butal or in estimate na lang. So yun ang isang problem natin, how to have good data sa ating sa Pilipinas. Okay, let me now quickly share to you this ginawa ng Cambodia on smart farming. Okay? Meron silang mega farm. There is this one company who are willing to invest on machinery, who are willing to invest on technology. They were given 2 kilometer by 2 kilometer area ng Cambodian government. That's about 400 hectares. Okay? Tapos balak nila magtanim ng corn and soybeans for export sa Thailand, sa Laos, sa Malaysia, for animal feed production, animal feeds. Okay, kaya corn and soybeans. So ang ginawa nila, they really analyze this 400 hectares. They have a lot of soil sampling na ginawa para makuha ang profile. They collected weather data and they try to integrate things so they can come up with a production schedule. And during harvest, andyan na yung mga combine, they could map out the productivity na areas. Alam nila ano yung mga high producing part ng land nila, low producing part, and they try to analyze bakit ganun, bakit dito mataas, bakit doon mababa. So the following season, they would know what to do. They can now make adjustments ng pH, adjustments ng fertilizer levels, ng water levels, and so on. Okay? Tapos kasama na rin dyan ang pag-collect ng weather data for the projected rainfall, pati na rin po yung pag-analyze ng insect incidents, insect damage incidents. May mga monitors silang nilagay dun sa kanilang area. Sana magawa po natin sa Pilipinas ito? Possible naman po, kaya sana. Okay? But we really need to get support. We need to organize ourselves, government and private sector. So what are the key messages that I have in this presentation? The ever-presence of risk. Andiyan po parati ang problema ng climate change, of high price fluctuations ng inputs. Ayan po. They are everly present. And this necessitates enhancement of productivity and total production efficiencies natin. We really have to organize ourselves and work things out how to really increase productivity, reduce costs, and increase our efficiencies. Then, andyan na po ang Agriculture 4.0. We need to realize that and integrate that in our farms para makinabang po tayo. How to do that? Yan po, malaking usapin po yan, pag-usapan natin. And smart agriculture takes advantage of new information technologies, okay, electronics technologies, mechanical technologies, and so on. And models to maximize productivities. Ayan po. So, maraming salamat po sa ating lahat. Sana po marami kayong natutunan for the different smart farming technologies that we have for Philippine agriculture. Sabi nga sa Japanese,